morning, everyone. Today we are talking about line graphs. Now, line graphs are a little bit different than bar graphs or pictographs because they usually show something that happens over time. So if you look at my graph here, it's showing the temperature of each day over the course of a week. So it changes as the week goes on. That's the main point of a line graph. And as you notice, you will see that these points are all connected with lines, which is also why it's called a line graph. The other important thing to note is every single number on our scale is actually attached to a line instead of a space. That is different than bar graphs. And even my days down here are attached to a line. Now sometimes it's hard to see like this, so sometimes people will instead take the end of this line and extend it out and write the day on here because then it's a bit easier to read. I just wrote really tiny, so it worked for this one, but it'll change up for the next one. So as we can see from this line graph, it looks like the temperature is slowly going up over the course of the week. That makes sense. It was pretty hot this week and it's gotten hotter as we got along with a few days dropping. So with this, we can answer a few questions. Let's go over them. What was the temperature on Saturday? So to figure that out, I take out my trusty ruler and I go to the line where Saturday is and I go up to where it connects with the line here. Usually it'll have a point, sometimes it won't. And at this point, it looks like it's in between two lines. So I'm going to look those numbers for those lines. 10 is here, 12 is here. If it's between the lines 10 and 12, and probably this one is 11 degrees Celsius. So I'm going to put that on the line right there. Another question you might be asked to do with a line graph is to find the average temperature. So that's when you add up all the temperatures and divide it by 1, 2, 3, 4, 5, 6, 7. Because there's 7 dots, we're going to divide by 7. So the first thing we need to do is we need to figure out what each of these temperatures are. So on Monday, that temperature was 4. On Tuesday, it's between the 4 and the 6, so that would be 5. On Wednesday, it is at 10. Thursday, it's at 8. Friday, it's at 12. Saturday is at 11. And Sunday is again at 12, just like that. So I'm going to add all of those numbers up and divide it by 7. So that's what I'm going to do down here. 4, 5, 10, 8, 12, 11, 12. So 10, 20, 22. 1, 2, 3, 4, 5, 6. 62 is the number I get. I'm just going to check that again. 4 plus 5 gives me 9. 9 plus 8 gives me 17, 18, 19, 20, 21, 22. Good. So now that I have that number, I'm going to divide it by 62. Or sorry, I'm going to divide it by 7. 62 divided by 7. 7 doesn't fit into 6. 7 fits into 62 8 times. 7 times 8 gives me 56. I minus them off. 12 minus 6 gives me 6. 5 minus 5 gives me 5. So I have remainder 6, or I can write that as 6/7. So the average is 8 6/7 degrees Celsius. Not a nice number this time, but sometimes that happens. Now, what if we want to create our own line graphs? Let's take a look about that down here. So here I have another lovely line graph, and we are going to do things with it. So, in the case of this question, it says create a line graph for Lainey. So Lainey here is a grade 4 student, and she's been recording her height over the last few months and seeing how it changes. So in January, Lainey was 130 centimeters tall. So over here, I'm going to look at my graph. Remember how this line sometimes is just an extension of this line. So this is my January line. And in January, she was 130 centimeters. So I'm going to start by putting a dot there. That's a very good start. Next, I'm going to go to February. February, she stayed the same. She was at 130 centimeters. So I go to February. I go up to 130 centimeters. I put a dot right there. Now that I have 2 dots, I'm going to connect those 2 dots with a line. Now this is important, grade 4s. You never connect nothing to your first dot. There's nothing here to connect. So you leave it as is, but as soon as you get 2 dots, that's when you start connecting them. Also, a thing you might notice is if you look at my scale here, I didn't start at 0. I wonder if you can guess why I didn't start at 0. I'll tell you right now, but I wonder if you got it. Well, if I started at 0, I would have had so many numbers to write out. My graph would have been so big, and then my video would just be in the top teeny little corner. That doesn't make sense. So sometimes you start your data a bit higher up. That way your graph can be a little bit more accurate and clear to see. Now when I do that, when you write out a graph, you usually add this little squiggle line. It sort of looks like a heartbeat. And that just says, hey, I'm not starting at 0. I'm starting at this high number. Your charts in your textbook might not have that, but it is a good thing to practice when you don't start at 0. That way people can know the graph is not starting at 0. Anyway, let's continue with our points. So we have January and February. Now we're going to go to March. March was 131 centimeters. So I go to the line for March, and then I find 131 centimeters, and I draw my dot. And then right away again, I'm going to connect my two dots. If I do it right away, I will avoid confusion later. It is always better to connect them as you draw your dots. And then we go to April at 133 centimeters. So April, go all the way up to 133. Whew, she grew a lot that month. And then I draw my line here. Very good. And finally, May, she's 134 centimeters, so I draw a dot at May. And I connect that. Now, you might get some questions with things like this as well. You might even get the average question again. The nice thing about drawing a graph and then having to find the average is you already have the numbers ready to average. So if I wanted to average this, I'd just add all of these up and then divide by 1, 2, 3, 4, 5. So there we go. That's how we are doing it. I hope you have a lovely day today, and goodbye.